Okay, so so we look on this first question. So first question, okay, the water flow from a large tank. Okay, flow from the large tank through a bunch of the pipe which discharge as a free jet. Okay, so discharge, okay, first of all, because of the, I mean, you have a tank and then the water will go through here as well as here. That's why you have 0.1, 2, 3, 4. So in these questions, it was kind enough, okay, that they already give you the 0.1, 2, 3, 4. So when you are doing the whatever calculation that you want to do, okay, you just mention, okay, from point A, point 1, point 2, point 3, point 4, it'll be easier for you, okay, so that you won't confuse. Okay, so then there will be two things here. Okay, first of all, free jet. Okay, free jet means, okay, when the water flow out, okay, because it says that free jet, which means that here will be at atmospheric, okay, ATM, and here also at ATM. Will it having some velocity on there? Yes. Why? Because the water will flow out freely. So flow out freely doesn't mean that the velocity is zero, but instead the pressure is atmospheric pressure. Okay, so that's why you see, both pipe at point 2 and point 3 were exposed to atmospheric pressures. Okay, so that's why here it has a further explanation, because some of the peoples, they might not able to understand, okay, what it means by free jet. So that's why then, which means that the pressure is in ATM, but the velocity will be something. It will be different. But how was it? And then of course, first of all, I mean, if you know, okay, since I mentioned there atmospheric pressures, velocity, you should know, okay, Bernoulli equations is using. So, and also here they ask you to give two assumptions based on your slides. You will have 5 assumptions. Okay, so the 5 assumption will be, okay, the flow must be in a streamline. I just write the what we call it, key point. Okay, because the complete answer you need to search your slides. I can't remember 4 or 5. Okay, 5 I think. Okay, that's streamline. Okay, the flow must be in streamline. The first one. Second one. Okay, no external heat. Okay, involved. Okay. And then the third one, okay, incompressible. Okay, although here incompressible. Okay, although here say 2, but I try to give you more as much as I can. Okay, and then can't really remember. Streamline, no external. Viscous flow. And last one I forgot already. All right, I remember I have 5. So this, please refer slide. All right, slide 5, if I'm not mistaken, the Bernoulli lah. Okay, so inside there will be one slide, okay, listed out 5 of the assumptions. Okay, so you just copy 2 of them from there, and you have to understand every assumption. Okay, so because if you just remember 2, in any case you forgot, then you lost a mark. So or maybe the question asks you 3, or maybe the question asks you what is the 5 of them. So better you remember everything. Okay, so next, calculate the pressure. I mean, now is the calculation. They ask you to find, okay, calculation the pressure and the flow rates. Okay, so some people will ask, okay, what it means by flow rate, what they want, because in, cannot, okay, because in the in our tutorial. So we have specified mass flow rate and volume flow rate. So which one that this question one? Okay, so for me, I also don't know. But if you ask me what I will do, so I will do both because they said flow rate only. They did not mention anyone. Okay, so you have to do both. Okay, so first of all, since Bernoulli, so you have point 1, 2, 3, and 4. So state out all the things that you know, okay, and all the things will be, okay, it must be P, pressure, velocity, and is, okay, pressure, and then the, what I call it, the height lah, okay, pressure 2, velocity 2, height 2, pressure 3, velocity 3, height 3, pressure 4, velocity 4, height 4. This is for you to do Bernoulli equation. But of course, when you do Bernoulli equation, you always need the volume flow rates, okay, which is Q equals Q in equals to Q out. This one I'll talk later. So let me fill up the blank first, see what we can find. First of all, okay, based on the questions, they ask, they want to find pressure 1. So definitely this is empty. Then they ask for flow rates, whether you are flow rate or what you call it, mass flow rate. So it will be AV, as well as mass flow rate will be rho AV, which means what? Which means that you need to know your velocity. Since you said 1, 2, 3, which means that you won't have the value of 1, 2, 3. But since this is what they are asking for, the rest you should have, else you cannot compare. Right, so fill in the blanks. How you want to fill in? Okay, first of all, you see 0.2 and 0.3, the atmosphere is the atmosphere pressure. That's why that's why you can put P2 and P3 is 0. P4 is surface, water surface. So also atmospheric pressures. Okay, so then water surface again, velocity is 0. So then the last one is the height difference. Okay, so remember for this height, we are calculating from bottom up. Pressure, rho GH, the H is calculating from top to the bottom. Okay, I mentioned this so many times. Okay, so please remember, if you are talking about height, the higher it is, the bigger value. For pressure, rho GH, the lower it is, the bigger the value of height. Okay, so anyway, so for this case, 1 and 3 at the bottom. So 1 and 3 is 0. I see. So basically, they are all zeros. I mean, majority lah. Okay, so because it seems like, I mean, it looks like so easy, but yes, it is. Okay, when you write 0, whatever this 0, whatever that 0, okay, you will get marks. Okay, because indeed it is a 0. Okay, but if you did not mention it out, okay, how I know? Okay, you understand about it. Okay, so that's why. Okay, so then this is 4 because from here you go up 4. That's why 2 is 4. From here you go up until the water surface is 7, then 7. No? Okay, so in order for you to do Bernoulli equations, so now everything will based on this table. This is meter lah. Okay, so then based on here, I cannot use 1 to compare first because a point 1 got 2 unknowns. So I will start with 0.2 and 0.4. We always use 0.4 lah. Okay, because 0.4 now have what I call it, 2. Okay, 0.4 has full of all information already, so it will be easier. So first of all, again, you write down the formula. P4 gamma 4 equals to, no need gamma 4 lah, gamma only, same water. I mean same liquids. V square 4 over 2g plus actually the z lah. Okay, z value 4. Z is the h lah. And then P2 plus V square 2g plus height 2. Okay, then you just fill in the value lor. So 0, 0, 7, P2 is 0, V square 2 over 2, G is 9.81 lah, okay, standard. Then plus 2, for 2 is 4. So then your V square 2 over 2, 9.81 equals to 7 minus 4, which is 3 lah. So it becomes 3 times 2 times 9.81. So it make your V2 equals to, of course, I straight away I what you call it, I solve everything lah, okay, including the square root, because square move over is square root. So 3 times 2 times 9.81 square root. So you get 7.67 meter per second.
Sir?
Yep.
May I know why is the 2 times 9.81? Why is not only 2?
2G ma, formula.
There is 3 formula. What should I use?
Either one. Either one you use. Okay, because either one you use, okay, which one you use, you also need to find
The first one,
you
the
also need
Bernoulli
to this.
equation.
Yes, they are always the same, because the key point are this. Which formula are always the same, but you do not mix lah.
No.
You do not mix.
Okay,
Okay, so
thank you.
then for, I mean, now you found your V2. Same thing goes to your V. Okay, BE 4 versus 2. Okay, I'll make it shortcut lah. Okay, I do not copy the equation anymore. Instead, again 4 because 4, so the first part will be the same. And then for 0.3 again plus V3 square over 2 9.81 plus 0. So V3 square equals to 7 to 9.81. So V3 equals to, again, okay, I just straight away square root lah. So just repeat. You just repeat the thing. Okay, but you get the, you get the mark lah. Okay, for both. That's it, look. Okay, so now you have V2 and V3. Then you can find your flow rate for both lah, mass flow rate and volume flow rate for 2 and 3, which you already done this. So how you find the flow rate 1 or velocity 1? Because you want to find flow rate. In order to find flow rate, you need to find the velocity. But it seems like Bernoulli equation cannot be used first. Why? Because yes, you can compare 1 and 4, but because P1 and V1 you doesn't have. So that's why you cannot use it first. So instead, so we have another one, which is this one. Q in equals to Q out. You see, how many in? So 1 inlet only and 2 outlet. So 1 to 2. Right? So Q1 equals to Q2 plus Q3. You already found Q2 and Q3 based on the V2 and V3. You already found. Okay? So, but of course, remember, your area have to find it. So let me tell you, area equals to pi r squared. If you use pi d squared over 4, it's okay, but do not mix. I see a lot of people, they use pi r squared over 4, which is wrong. Okay, so either you use pi r squared or, okay, pi d squared over 4. Okay, so A for 1 because 50 mm, everything has to be in what you call it, meter. So 50 mm become 0.05 meter. This one 0.03 meter, okay lah. So this one 0.02 meter. Then only you convert pi for 1, 5, 0.025 square. A2, again, you list out everything, you have mark. Okay, pi 0.01. For, oh sorry, this is 3. For 2, pi 0.015. Okay, so there you can find Q2 and Q3, and based on here you see A1 V1, this one A2 V2, A3 V3. So you have area already, all area you have, okay, based on that. Then V2 and V3 you got already from here and here. Then you will find a V1 equals to what? And then again you do mass flow rate, volume flow rate for 0.1. So you found everything. Okay, you found everything for this part. So once you found, okay, then because now then only this moment you will lack one of the information, last one, which is pressure 1. So then only you do Bernoulli equations 4 versus 1. You want to do 1 versus 4 also can, it's fine, perfectly fine. Okay, but for me, I always, my own practice lah, okay, I always do the complete one on the left hand side. Okay, so but it will be fine. Then, okay, you will find P1 equals to anything. That's it. Okay, so utilizing Bernoulli equation and the, what I call it, show you 2 pages. No, 1 page. Okay, so then you can do it. Okay, so this question, that's it. So how, what question you wanted to ask? Okay, have you tried? You must try. Okay, and you must try and do until you can do it without referencing. Okay, so any questions? Yep.
Sir, can you just repeat what was the last step?
Okay, last step as in you are looking for P1, right?
Yeah.
Okay, so if you are looking for P1, yes. Now you use back Bernoulli equation again. Because
Okay.
because now you have all the information except P1. Then you can use.
Okay, perfect.
Then you just everything just put in. Okay, and the value are quite simple because all the other pressure are 0, height are in either 0 or certain 4 and 7, which is a nice value. So it will be quite easy. So just that you need to know and you have to put it in all the values. Okay, so this question okay. Okay, then I go to the next question. What is this? Oh, okay. So this is the hydrostatic force. Okay, so as you can see, this is what a dam. Okay, so this dam has 7.5 meter depth. Okay, HR. Okay, so then you say determine the hydrostatic force exerted at the dam site and the depth of the center. What it means? They are asking for what is the value of hydrostatic force and its location. And before you do, this is vertical plane. Some of you are memorizing the force. So for this case, it called horizontal force. So when you're memorizing these chapters, you do not just okay, vertical is like this, horizontal. So and when you discuss with your friends, surely you get confused because your vertical term, maybe you are referring to vertical plane, but your friend's vertical refers to vertical force, so which is another thing. Okay, so when you tell or when you discuss with your friend, you must mention everything. whether you are mentioning or whether you are mentioning vertical plan or you are mentioning vertical force, because both are different. Okay, then your friend will know also. Then because else you guys both you talk one, he or she talk another one. Then mixed together, then you guys getting more and more confused. Okay, so anyway, so first of all, hydrostatic force is rho g h c a. Okay, hc for vertical plane is half. Okay, which is 7.5 over 2. Area. Okay, so area is the vertical plane area lah. Okay, so because you see the width is 5 meter, so basically it's like this one, 5 meter. So the area that you're touching is here. But you see, okay, it's a trick. Okay, although they show 9, but your water is not actually providing the force for all 9 meter, right? The height, because the water height, the water depth only 7.5. So your area will be 7.5 times 5. Okay, so for density, of course lah, normally we use water. So then it will be 1000, 9.81, 7.5 over 2. Area is 7.5 times 5. Then you can find a value. Okay, so that's why very simple lah. So it will be 1.38 mega. Some you write full is fine, or some you write prefix is called, okay, Newton. All are fine as long as you're referring the same thing. Okay, so Newton, because hydrostatic force, so it will be in Newton. That's it. Okay, this is how you find, I mean not the whole question, but this is how you find the hydrostatic force. For location is called YR. Okay, so because it's a vertical plane, so vertical plane is very easy. 1/3, or they say what? Okay, the depth, because they want depth. I mean whatever first lah. Okay, I will draw that. Okay, so this is from front view lah. Okay, your water level is here. Ignore the 9, because what we see will be based on the water. Okay, 7.5. So the location will, for vertical plane, it will always 1/3 from bottom. 1/3. This is F. Okay, location is always 1/3. So will be 1/3 of 7.5 meter. Okay, this is from bottom. Why I'm mentioning this? Okay, let me find a value first lah. Okay, it will be 2.5. Why I'm mentioning this is because they say what is the depth of the what I call it location. When they say the location as a depth, which means the location are calculating from water surface, because else how you consider a depth? Depth, which means going down ma. Okay, so then equals to 5 meter from top. So you see 2.5 2.5 is here. So of course here is 5 meter long. So 2.5 plus 5, 7.5 meter long. So when it say, okay, the location only, when they specify, ask you to find the location, you can write either one, but you need to mention that. You can just write 2.5 from bottom, it will be fine. But now the question specified depth of location. So that's why you need to write 5 from the top. Okay, so this is a hydrostatic force for vertical. Okay, vertical plane. Okay, again, do not confuse. Okay. So, any questions? Any questions for this case?
Sir, I didn't understand the part where from like the surface. I know how to solve it, but like how? Which one is the answer? Is it the 2.5
5.
or is it
5. For this case, must be 5 because the question has specified depth. If the question only says, okay, find the location of the hydrostatic force, there will be 5. Both are correct. Because they specified depth. Depth has to be from the top calculating downwards. Then it's only called depth.
okay? Yeah.
Okay, so yeah, so this is how you do lah. Okay, then okay, what is this? Okay, so this is the dimensional analysis. Okay, so if you go through the tutorial, you will find that in tutorial, the dimensional analysis is actually circulating in few question only. Okay, which is pressure, force, velocity, not much. Okay, so because of our what I call it syllabus bounded, so that's why the question can be asked is not much. So anyway, so this is one of the questions. It will be almost similar to yours tutorial lah. So anyway, so first of, I mean the steps are always the same. So a model airplane is being taxed, okay, by using what I call it wind tunnel. Okay, so we know that, or say like if the velocity, aerial, density, and coefficient drag are known, okay, so which of the following would be correctly yield the drag force? Okay, using dimensional analysis. Okay, so so then that's why they ask. Okay, so they are saying, okay, F the drag force is a function of velocity, area, coefficient, and what? Or density, forgot already. Okay, so so that's why. Okay, this is the first step. You need to list out the function. And hold on. Then the second step is you. Let me check the coefficient. Okay. So next is okay. Okay. F D V A C D S T. So 5. So K is 5. So then what you do? Okay. Force. Force is Newton. Okay. Newton. The unit is. Let me check. Newton is F equals to MA. Kg meter per second square. Okay, so it will be mass. Okay, MLT system. Mass length times square. Velocity is length. Okay, length over time. Area, of course, length square. Coefficient. So what is coefficient? Coefficient normally is a value. That's why it's called coefficient. Okay, so like for example, coefficient of frictions is a value. Okay, so that's why normally it doesn't have any unit. Okay, so let me check. Let me confirm. Doesn't have. It has lah. Okay, but let me check. Let me confirm the coefficient. So it doesn't have like it's 1. So density is actually it has lah. Okay, just that. Let me check. Okay. Let me check. Let me check. Let me find the value of coefficient. I mean the unit of coefficient. Drag coefficient.
ML over T squared.
Oh, you get already ml.
The same as drag force.
Drag force.
I'm
No,
not sure.
no,
Correct.
it's not. So because okay, how to say? Okay, drag force is 1/2 rho v square a then cd. This is the formula. I mean, this is the original formula. So this is Newton, okay, or we call it kg meter per second square. Half is fine. Then density is kg per meter cube. Velocity is what we call it, meter per second, because square, so square. Area is meter square. Then this is the unit for CD. So then you revert everything. So you found that kg and kg. Then meter cube. So cut, and here can cut and cut. Oh, okay, CD is 1. So no unit. Okay, so no unit. Where's my area? So no unit lah. So CD is 1. Density is, of course, like I said there, kg, mass over length 3. Okay, so what you use here, okay, so because once you do everything into the animality system, then you need to check. So whether you use M, L, and T or not. If you three of them all existing, then R equals to 3. If you did not see any one of it, okay, one of it, I mean, like for example, you did not see T at all, then R equals to 2. Else, normally it will be 3 lah. Okay, but right, you have more. I mean, because R, which means basic quantities, but because like I say, your syllabus basic quantity is only limited on mass, length, and time. So that's why maximum will go up to 3 only. Okay, so anyway, so that will be pi equals to k minus r. That's why you get 2. So 2 means what? 2 means you need to do pi 1 and pi 2. So after that, because you know already, you need to have pi 1 and pi 2. So you need to decide your what we call it, repeating variable and non-repeating variables. The first one must be the first non-repeating variable. You cannot choose. Like it or not, you cannot choose. Okay, and the second one, you cannot choose until you select all the repeating variables. Okay, how many repeating variables that you need? There will be, you can decide from so many perspectives, whether you are deciding from, okay, now you have R equals to 3, so you need 3 repeating variables. Or you can say, okay, non-repeating, I mean, you have 2 pi, so you need 2 non-repeating variables. So which you have 5 factors. So then 5 minus 2 is 3. So you need 3. Up to you how to know how many repeating variables that you need. Okay, for this case, you need 3. For me, I would say, because I do it from the perspective of, because R equals to 3. That's why I need 3. Okay, so then how do you decide? So the 3 repeating variables must be selected from geometry variable, kinematic variables, and fluid properties. Okay, if you refer to other books online, okay, this term might be different, especially the last one. Some we call it dynamic variables. Okay, but for me, I prefer fluid properties. Okay, because this category is talking about or is selecting from those units that talking about the fluid. Right? So first of all, geometry, area lah. Right? No more already. Kinematic is something that moving. Okay, cause it move. Okay, the higher the value, the faster it is. For example, so velocity, and then the last one, properties is density. So then the next is I mean the last the unused variables will be automatically becoming your non-repeating variables. Okay, so after you select them, so you start to write pi 1 equals to ft. Start with non-repeating variable and followed by repeating variables. A, B, C. It will be fine, okay, if you choose V density first or whatever, because the ABC, you will change according to how you place them. Okay, so then FT, okay, you have done all the formula already, so you just bring it in. Okay, then area L2A L over T B and L3 C. Then it must be equals to MLT 000. Okay, so start from M or L or T. It depends. Okay, you can just go through every time M, L, and T, M, L, and T, but it always have a fastest way. It depends. If you don't know, don't try. Okay, so then I will start from T for this case. So T0 equals to T negative 2. Why? You have this one, no? T negative 2. Then T negative B. Why? Here at the bottom. Okay, so the bottom is negative 1. Negative 1 times B is negative B. So 0 equals to negative 2 minus B. So B is negative 2. And now I get B. Next, I go M. M, okay, first we got 1, okay, here. Then you got C. So which means 0 equals to 1 plus C. So C is negative 1. Then you go L. L, 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 you see? And then L. So many L, all right? So L, and then L2A, okay, because here 2 and A, so times 2A. So L, B, and some more L negative 3C. So you get 1 plus 2A plus B minus 3C. So based on the findings, so 1 plus negative 2 plus B minus 1. So become 1 minus 4 plus 3, sorry. Plus 3. So you get your B equals to 0. Okay, so once you get A, B, C, you just rewrite pi 1 equals to F B. Oh, sorry, you got B. I made mistake. Okay, what I know is the B. It's not A. The negative 2 is on. It's not. It's on B. Right. Okay, so 1 plus
Sir,
2A.
how did we get minus 3C?
ML3 ma.
Oh, L3. Okay.
So minus. At bottom, you have a minus. Then CC lah. And minus plus. So or the same thing lah. Okay, 1. No. 4. 4 minus 2 is 2. So 2a plus 2 equals 0, a equals to -1. So once you get pi ABC, you just rewrite FD a -1, v -2, density -1. So since all negative, so I rewrite FD equals to a density v2. That's it. This is for your pi 1. Pi 1. Pi 2, repeat. Again, like I said, start with non-repeating variables, CD, and then followed by all. Okay, so you can keep the same, but you also can change because, change the position. Okay, you cannot change other stuff, of course, but you can change the positions. So CD is 1. Okay, then A is the same thing, right? So that's why I copy. So I always love to repeat because I can just copy. ML3 was C equals to MLT000. But of course, for now, you cannot copy anymore. Okay, so first of all, T. Start with T. T0. For this here, you only have this T. P negative B. So 0 is negative B, B is 0 lah. Okay. Oh, then all are 0. Correct. So all are 0 lah. Okay, but anyway, so just prove it. M equals M 0 equals to MC. Okay, so 0 is C lah. And then L 0 is for L2A, L2B, and then L negative 3C. Okay, so then 0 equals to 2A plus 2B minus 3C, whatever. So A is 0. Okay, so which means that pi 2 equals to coefficient only, because all are 0. Okay, you cannot write pi 2 equals 0. It's a good question here. Okay, you cannot write pi 2 is 0 because 0 0 means nothing, but power of 0 is 1. That's why the CD is still there. It did not miss out. So which means that it's telling you, okay, pi 1 equals to pi 2 this is a format, equals to A over V square equals to CD. Okay, so your pi 2 is not 0. So that's why. Okay, so it's different. It has a big difference if you say pi 2 is 0 and pi 2 is coefficient. Okay, so that will be a big difference. Okay, so this is what it means. Okay, so this is the answer. Okay, so this is the complete final answer lah. Okay, so of course you cannot just give me this. So in this part, okay, it will be in question 5. In the exam, different question, but what I wrote here, you have to write, of course, different factors, because this is not a exam question. So, but what I have here, like for example, I say K minus R. So in exam, you have to write K minus R and then equals to what? Okay. So everything you have here, so you must have in the exam, okay, in order to get all the marks. You cannot give me a final answer like this, okay, because I will suspect that you are copied from somewhere, okay, because you cannot prove that you are doing it. So you have to show everything. Okay, so and then of course now, okay, drag force. Now this is the second part. Okay, so you have a formula, okay, related to FD equals to, FD divided by A, what? A again? Okay, A density V square. Okay, so because this is increment and decrement, so to check the drag force lah. So then how you do is will be like this lah. One model, one prototype. Okay, so let's say lah, okay, this why we need to do this? Okay, because it will say, okay, if you're in your prototype, if your density is increasing 3 times, only density. So what to do? What happens to the drag force? Will it change? So then, so based on here lah, okay, so you see, okay, so I'll do this lah. Okay, how I do? Okay, I will do it in very proper way lah. Okay, because if you can write in this way, then it will be the best lah. Okay, so FD equals FD model area model density model velocity square model equals to FD of prototype A prototype density prototype and V square prototype. Okay, so now it says density of prototype equals to 3 times of density of model, with the rest are the same, which means that AM equals to AP, VM equals to VP. So what you can do in this case, so you see, since AM is AP, so you can cut away because they are same value, like 5 and 5, so you can cut away. Same to goes to here, even though they are, we call it different. Okay, even though they are square, but same value square, you always becoming the same value. So your formula will be left in density of M equals to F density of prototype. So now you already mentioned, or the question already mentioned, prototype of the density is 3 times. So it can be cut, okay, because now both are density of model. Okay, so then it makes your density, drag force of the prototype, okay, bring up is 3 times. See, so this is the proper way lah. So that's why then here then the changes, okay, the drag force will increase 3 times, and this is the proof. Same thing goes with another one. Okay, so another one, of course, the answer will be decreased 2 times because it says, okay, so it depends, okay, but how you do, okay, I mean, you can use your own way, because in this case, it's not really stretching on how you do it, how you find it. You can look on it and you figure it out. So make sure you figure it out correctly. I did not really request this proper working, but at least the final answer has to be the correct one. Okay. All right. So this question, any question? This part. This part, dimensional analysis. All the questions are almost the same because I mean they are circulating in these few questions. Okay, method 100% similar. Similar means steps are all the same, but value unknown, they are all different. The unknown that you are selected for non-repeating variable might be different. But those units are the units that you see always. Okay, any question? Okay. Okay, if okay, then I go to the next questions. Let me see. Okay, so this is the what you call it, loss, minor loss. So first of all, HL, okay, for major loss, okay, it will be F L over D V square over 2G. For minor loss, major minor, okay, is K V square over 2G. So basically, for major, you require to find F. For minor, you require to find the K. Okay, that is the most important case. Okay. First of all, okay, they already mentioned, okay, you are working as an engineer to analyze the design of the new piping. Okay, so you are using water. Okay, you have this kinematic viscosity. You see the unit is this. Okay, raised up to 5.7 cm above the exit on the vertical pipe. Okay, which means that it goes up. Okay, so attached to the three horizontal pipe segments. Okay, 1, 2, 3 lah. Okay, because you bend, you got bending. So then the total length of the 3 cm cast iron pipe between point 1 to the exit is 53 cm. Okay, which means the length is 53 cm or 0.53. So the company target is to minimize the pressure needed, okay, which means to reduce the loss lah. Okay, so construct the control volume, label the inlet and outlet. Of course, control volume is whatever this lah. Okay, this is the control volume. Inlet, outlet, because for this case only one outlet, one inlet. So basically like this lah. If you have two, then we have to do it lah. Then next is calculating the pressure. Okay, so you see, when you construct or when you considering the major and minor loss, so you will be involving in the Bernoulli equation, because the HL, it will be placed or used with the Bernoulli equation. You cannot use with the momentum or whatever, okay, because it is how it being used. Okay, so for this case, okay, when you are considering the losses, which like you asking, okay, actually in Bernoulli equation it has three type of the equations. Which one you are selecting? Again, yes, three of them is okay, it's fine. But because you selecting different one, when you adding the minor loss or major loss, okay, or the HL lah, you might need different addition unit beside the HL. If you use the first one, which is what I always use, I use 0.1, 0.2 lah. Since here using one also. This is the one that I use, which is the first Bernoulli equation, first Bernoulli equations. Then 0.2 ma. So you just plus HL, whatever you want to plus H, minor or major, whatever. But if you use others, okay, for example, yep.
Good question. When do I know which to use the second formula or when to use the first one?
That's why I say, again, it's fine. Just that, okay, if you use the first one, when you need to consider head loss, you plus HL, that's it. But if you consider other, the second, the third one, like for example, you are considering this, like this, right? And then yeah, correct, this, and then V square over 2 plus G height. Okay, so same lah, 2, 1 and 2 gamma V 1 2 plus G height 2. So if you want to consider HL, yes, you have to plus GHL, not only HL. So it depends on which one you want to add. I mean, which one you want to use. Then when you want to add the HL, yes, three of them you can use for the head loss, but because of different one, so when you add the head loss, you might need to have some modifications. This is how you do. So that's
Okay.
why for me, myself, I used to use the first one. That's why I always, I mean, when I want, I just plus HL, easier. But for your case, if you guys already, what you call it, used to use the second or third one, make sure that when you add HL, you have to add something beside it. Because it could be G, it could be the specific gravity gamma, because based on the equations. The third one is pressure equals to whatever, blah, 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 blah. So if you really want to know, okay, how it will be being added, it always tally with the unit of height, you see? It always tally. So whatever the height term you add, you have to add the same thing for your head loss. This is how you do on the formula first. Not yet starting calculation. So this is how you put it in, because this is very important. Okay, so this is the one. Okay, then only you do. Okay, now they ask for major loss first. Okay, so in order to find the major loss, this is your major loss. So V, you already have V. Okay, you already have V. What I mean is, okay, you have to use the one of the velocity. Although, okay, there will be some, what we call it, problem, okay, from you guys, okay, because first you understand already, okay, this formula is put like this. So I put, because point 1 is entrance, point 2 is outlet. Okay, so outlet here lah. Okay, so here is the outlet here. Okay, so both, okay, having different velocity. So based on the HL, which one you want to use? So there might be a question from your students. So the point is you have to use before. Okay, you have to use the before one, which is point 1. But anyway, so first of all, okay, in order to find the F factors, okay, HL is major, okay, FL over D, V square over 2G, and is V1. It always V1. Okay, before I would say, okay. Then L you have already, diameter, diameter you have already. So you see, you have everything. Okay, you have, I mean you have quite a lot of numbers already. But in order for you to find F, first of all, you need to find their real number. Real number, the formula have given in the formula sheet. So rho Vd over gamma, or we call it Vd over kinematic viscosity. The formula or the question is giving kinematic viscosity. So then you have to use this lah. Okay. So then, okay, the point is V. How you find the velocity then? Because there is no, well, even though you know which velocity should be used, but there is no velocity here. You cannot use the 1.12 because although it looks like very similar to velocity, but it's not. Velocity is meter per second. This is kinematic viscosity, which is this one, not velocity. You do not do that. Okay. So what to do or how to do is you have to use what I call it, Bernoulli equation. Okay, so you have to use Bernoulli equations. Let me think. Okay, you can use other method also. Okay, because I found that there is two methods. Okay, point 1, point 2, point 3. Okay, how to differentiate? I draw this view from here lah. Okay, this is the pipe. Point 1. Okay, then you have the meter, right? Then it go, and then it go come here, and then go back, and then it go up here. Okay, so this is 0.2, this is 0.3, and here is 10 cm, here is 5.7 cm. Okay, so we have 3 points. So in case you cannot see it clearly, okay, so this is from side view. Okay, so I use Bernoulli equations between 2 and 3. Why are you using 2 and 3 but not 1? Because 1, I do not know the velocity as well as pressure. I have 2 unknowns, never can use. Then why I can use 2 and 3? Because for 2, pressure 2 and pressure 3 are equal, which is 0. Velocity 2, I don't know. But velocity 3, it will be 0. Why? Because it is at highest point. Height 2, it depends. Some people say 0 and 5.7. Some people say 10 and 15.7. Both are correct. But of course, like in meter. Sorry, this is 0 0.1. And this is 0 0.157. Up to you. You can, because as long as Z2 and Z3 between they are 0.05, then okay already. Okay, so then you use Bernoulli equation. I did not copy I did not write again because I write here already. In exam, you should write. So 0 plus V2 square over 2G, 0 lah. Sorry, 0.1.
Sir, how did you get 0.157? How did you get
my reference height will be starting from the bottom. From here to here and from here to here.
Oh.
This is 2, this is 3. So 10 cm is 0 0.1.
Yeah.
15.7 cm is 0.157.
Oh.
So then here is 0 plus 0 plus 0.157. So you bring over, so this is 0, cut away. So you get 0.057 equals to 2 v square over 2g. Okay, so then v equals to square root 2 9.81 0.057. Check 2 times 9 2 times 9.81 times 0.05. So your speed is 1.058. Okay, once you have this, then you put it in, continue here. Okay, so then equals to, sorry, 1. It's not 1.0758, correct. The diameter, how much diameter already? 3 cm. Okay, 3 cm is 0.03. Kinematic viscosity 1.12. Okay, so then divided by 1.1297. So it is 28,000. So this is turbulent. You must mention, else you cannot continue because it is turbulent. So the F factors you have to find from the graph. Okay, so the F factors. So then, of course, this is turbulent. So that's why let me show you the chart. Let me open it. It's my chart. Oh, did not have the Okay, this one. Okay, so this is the formula sheet okay, that you will see exactly like this. Okay, so anyway, we go to this chart first. Okay, first of all, the question say cast iron. Based on the formula, based on this, you see, cast iron, the roughness is 0.26. Okay, based on graph, based on chart lah. Okay, movie chart, 0.26 mm for cast iron. So, but what they want from here is here, okay, this one is roughness, relative roughness. So relative roughness is over D. So then you have to make it into the same unit. So normally I will do in this way lah, 0.03. So you can find it 0.26 divided by 0.03. So you will get 0.00867. Okay, or we call it 8.67 times 10 power of negative 3. Okay, 3 cm. Correct. Exactly. Okay, so now you have this value and this value. Okay, again, this called 2.8 times 10 power of 4. Okay, so why we need this? Okay, because here, first 10 power of 10 power of 4 is between here to here. The next is 10 power of 5. Okay, so 2.8. So this is 1. This is, sorry, this is 1. Then this is 1.5, 2, 2.5, 3. So what we want, what we are, 2.8. So 2.5. So it will be roughly here. You never find an accurate one because you are based on the table. In future, we have a online software, okay, which means that you key in exact the value 28 blah 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 into the website, and then they will generate for you. They want accurate, but for here we just teach you how to use it. You have to understand the whole ideas. All right, so that's why the answer sheets or the answer scheme will have a range. Okay, as long as you are taking between here this range, you always correct. But what if you out of them, then get wrong? Okay, so first of all, okay, so here, okay, so I will do the straight line first, roughly lah, roughly. Then the roughness will be 8.7, 0.87, 0.8 here. You see, 8, 6, 8, 9 or whatever. So it will be roughly here. So for this case, you will follow it goes, okay, follow, and you see the line is start to curve up, so you also following to curve up until you meet the point. So the intersect point there, then you go horizontally. So it will be roughly 0.39. Okay, so I click already. Anyway, so F equals to 0.39. So now you have F, you have this length, you have this, you have velocity, you have G. And then you can find, okay, HL equals to 0.39, 53 cm, which is 0.53, 0.03, velocity is 1.0 square over 2, 9.81. So this is your HL. Yep.
You're still sharing the graph.
Oh, okay. Oh, okay, because let me put it in. I will combine it. Never mind, I stop sharing, and then I go for okay. So I see. Then you fill up all the values since you found F. So then you find your what you call it, HL. Okay. So, but the question is not asking what will be the major loss, but it will, instead they will say what is the pressure. So that's why you have to use the Bernoulli equations between 1 and whatever lah, 3 for example, because for 3 I have everything easier. Okay, you want 2 also can. Okay, 2 also can, maybe 2 lah. Okay, maybe I'm using 2. Why? Because in 2, velocity 2 equals to velocity 1. So it will be easier, I can cut away. So then P1 gamma plus P1 square over 2G plus height 1 equals to P2 over gamma plus P2 over 2G plus height 2 plus HL. The HL is this one. I did not calculate. But the rest, P1 is what we want. V1, V2 is same thing, so gone. Height 1 is 0 because it's bottom. So then equals to P2 is 0, right? Because outside already. Then height 1 is 0.1. Z2 lah, Z2 plus HL. Then you can find your pressure one. Okay, so until here, okay or not? Okay, if you have any question, you can ask. Okay, until here, so you are looking, you already look for the pressure. Okay, pressure one. Okay, next, C. Okay, you suggest a new system by selecting the pipe makings by using this galvanized iron. Okay, support your answers showing the percentage of the. So basically, you just redo everything by, I mean, the rest, everything are same. Every value are almost, I mean, every value, I would say, every value are same. Okay, except, I mean, let me give you, except this, and therefore this. Because now you are using a different pipe. The real number still the same thing, whether you want to show it or not, because it's not affecting. But what really affect is the roughness, relative roughness, because these two are changed, so your F factors will change. But the rest still the same. Okay, so then you find out a new pressure value and find the difference between the pressure in pressure 2, B and C. And then you find the percentage different. That's it. So in terms of working, you need to write out the similar one. You need another page, I would say. So, but then, yeah. So, but then they are actually just to find out what will be the difference. The steps are all the same. Okay, so, okay.
Sir, just a quick question for the pressure one. So it will be P1 over
Gamma.
which is
You are looking for P1. You are looking for P1. Gamma is 9810 lah. It's a value.
which is water times gravity, right?
Yes, correct. Water density times the gravity. So which means 1000 times 9.81. Then the rest, HL, the value here. Okay. So then I go to the last questions. Okay, last question is the hardest. Why? Because it involves the momentum. So like it or not, it will come out. Okay. So anyway, so first of all, you can see gasoline. Okay, you use a gasoline. So at 20 degrees Celsius, it's flowing at the V1 equals to 12 5 cm. Okay, pipe. Okay, which you have a suction of 10 equals size of the hole with V3. So here is V3. Okay, 8 meter per second. Okay, so this question is very, very similar to one of the questions in your tutorial. The one that have many holes, that one. One question only, you flip back. Okay, similar question. Okay, so then first of all, okay, they ask you to find the calculate the volume, flow rate, and mass rate. Now for this case, they is specified, so both you have to find also lah. But for point one, since you have this, you have velocity 1, you have velocity 2, and you have velocity 3. So Q equals to AV, mass flow rate equals to rho AV. Basically, you can find everything. So what you are need to calculate at first is you have to find A1, A2, A3. Again and again, pi r square, pi r square, pi r square. For 1 and 2 are same because they are same. They're same type. For pi, for area 3, slightly different. Okay, first of all, each because you have got 10 small hole. Okay, I draw 10 only because I said already. So then any information 5 cm. Oh no, this is for it. Okay, 5 cm. Oh, so you cannot find this. Okay, but you can, what you can find is Q1 equals to Q2 plus Q3. How many in equals to how many out? You already can find Q1 because Q1 equals to AV is pi cm, pi r square 0.025 square. Q1, Q3, actually Q2 the same thing, but the speed is different. Okay, the area is the same. So then you can find Q3 here. Okay, because one inlet, two outlet. So very simple, you see. That's it. And then mass flow rate is all the Q1, Q2, Q3 you multiply with the gasoline density. It already specified it's gasoline, then you do not use 1000. Cannot. All right, 680 there, show already. Okay, so then, okay, at B, okay, I assume no issue. Okay, for A, I assume no issue. If you have, then please stop me. Okay, so for B, okay, now they reverse. Okay, now they ask you to find, okay, how many area diameter you have for each suction hole. So based on the question A, you will find your volume flow rate. Okay, so the volume flow rate will be, okay, let me check. 0.02 square. Your volume flow rate Q3 will be 0.0039 volume. Okay, volume. So this volume flow rate, this value is A3V3. So which you know already, velocity is 8. So you got area of 0.0005 meter square. But you see, yes, although here say area is 0.005, but please remember that this is done by the area are total of 10 equal hole. So which means one hole area is actually 0.00005. Just divide by 10. So this is something that you need to take note. So then again, area equals to pi r square. So you do okay, 0.05 equals pi r square. Then your r will be, so first of all, divide by pi square root 8. So 0.0125. And diameter, because they ask for diameter, 0.25 meter. Okay, remember 10. So that's why you need to divide by 10 before you apply the formula of pi r square. You cannot apply in the last way. Okay, you find the R, then you only divide by 10. Cannot. Okay, you have to do it first because the area divided by 10, not the diameter divided by 10. Because area is like this, like 10 diameter and 20 diameter, the area will not only increase double. It might be 6 times, 5 times bigger because this is circle. The bigger it is, the more increment. So that's why you have to divide the 10 first. Okay, so this part, any questions? Okay, so next, okay, the third part, okay, C is the force. Okay, before you do the force, you must understand summation of force equals to m dot v2 minus m dot v1 before minus after. So I always say right hand side is so simple one. M dot you have already. Okay, so m dot follow. Okay, before and after. Okay, and they already mentioned fx. Why? Okay, because the tree is going up, which is y value. So we will be not considered in this x direction. So what you need to consider here will be m dot 2. Then I did not find really the value. Okay, but you can copy from the A. Just that I did not write full, so I did not know the value. So right hand side done. Left hand side force. Okay, for force wise, okay, it's very easy. So in practically there's a lot. There's a lot of force that you need to consider. But for our case, the force that you need to consider will be what you call it, pressure force. Okay, weight and reaction. So reaction you always need, but pressure and weight will be only coming out. It depends. Okay, when the pipe itself is moving, weight is not considered. So at the end, your left hand side will be only considering pressure force. Okay, PA is pressure force because pressure equals to F over A. So F equals to P times A lah. Why I put the triangle? Because it has to be later on I'll show you. Okay, minus the R. Okay, so R is the reactions, or we call it TFR. Okay, TFX. Okay, to be specified or to be fixed into this question. So how you find this difference in between the pressure area? So you have to find P1A1 minus P2A2. It always like this. Okay. Then minus T XX equals to m dot 2 minus m dot 1. That's it. If we all the value, P1 you get already, P2 you get already, area is this one, pi 0.025 square. So which means that you get everything here. TFX is the one that you are looking for. M dot have already, M dot 1, M dot 2 you have already. 10, 12. So we basically you have everything now. Then you can complete. Okay, so because they ask for X axis only, so that's why you doesn't need to consider those things at Y axis. In normal question, you need to decide both. It's not mentioned. But for this case, it is kind enough. It gives you what you call it, selections. I mean, not selections. They already mentioned. Okay, so then again for D, they already mentioned. Okay, to show. Okay, they already mentioned the Fy is 0, definitely 0. So you need to explain why it will be 0. Okay, so you see, so now for y-axis, okay, again the same formula. One. Okay, but for this case is 3 minus 1. Okay, because up. Okay, but your v1 is horizontally, so this is 0. Okay, this is 0. 3, you got two parts. One is here, one is here. See? So you will say half m dot, okay, that is having velocity 3 minus half m dot velocity, this is 3. Velocity 3. So minus 0, this 0 is 0 lah. Okay, equals to summation of f. Okay, so f equals to 0 because both are same. So this is one of the way. If you do not know, then you can use other methods. Like for example, you can verbally explain. Okay, because same amount of force, the same amount of the volume flow rate that going up and down with the same speed. Therefore, there will be no resultant in the force in y-axis. Can also. Okay, so it's up to you how to explain, as long as you can show, but not simply say, okay, Baba, I mean, not simply just say f dy equals to 0, this show. No, you have to give a reason. A reason is because they have a same mass flow rate that going into opposite direction with same speed. Because you must mention both, because if even they have a same equal amount of mass flow rate going up and down, but if their velocity is different, the force creating will be different as well. So that's why now, because now going up and going down speed and the mass flow rate are same, so definitely they're the same, and definitely they will cancel off each other. Then only you can say no force is created. So this is this part lah, how to explain. Okay, y is becoming 0. Okay, so so these questions. So any questions? Any questions for this case? So I know the momentum is the hardest lah. I would say the hardest in this the whole thing. Okay, that's why in exam I will the momentum will only come out once in each time lah, and it will be not the whole questions. It will be a certain part from the questions. So, but then it will be existing. Okay, so any questions?
No questions, sir. Sir, just should we focus more on this revision or the first revision?
Again?
Should we focus more on this revision or the first revision?
This revision.
This revision? Okay.
This version. Make sure you know how to do lah.
What would question 6 expected to be?
What do you mean?
Because these are 5 questions.
Criteria will be exactly same as the final, which, like for example, the 5th question is the dimension analysis. So in final, I mean in resit will be the same thing. The 5th question will be dimension analysis. So the 6th question is pressure loss, heat loss. Then the same thing. The format wise exactly the same, because yeah, this is what we do lah.
We already did the head loss. So what, like, because question 4 is the head loss question.
Yeah, correct. So some more you have Bernoulli, sorry, not Bernoulli, the manometer.
Oh, okay. Yeah.
Manometer, buoyancy. Okay lah.
Okay. Yeah.
That's it lah.
Yeah. Okay. Thank you, sir.
Okay, perfect. Okay, so if doesn't have anything, then yeah, that's it lah. Okay, so please try again. Okay, so make sure that you know how to do as in, do it without referencing. Okay, because I have asked few students. Okay, they claim that they know, but as the end, then the result is quite bad. And I asked again, so since you say no, why it come out like this? So turns out, okay, they know, okay, they know the questions, they know the answers, but without referring, they actually do not know how to do. So in exam, that's why they cannot do also. Right? Make sure you know how to do until without referencing. You can write majority, because if you write majority, somehow I can help. Else, I really cannot help. Okay, so that's all lah. Thank you. Thank you very much.
Sir,
Okay.
just one
Yep.
more question. Will the water gates, will
Yep,
they
yep,
come,
yep, yep.
will they come in the final?
That is hydrostatic force. Yes, it will come out, but it will be depends which type is coming out. You got vertical, incline, and horizontal.
So a water gate will be coming out.
Yes. Yes.
Okay, perfect. Thank you, sir.
Okay, cheers. Okay. Thank you. Thank you very much, everyone. Good luck. Okay.
Sir,
Yep.
nothing. Thank you, sir.
Okay, okay. Thank you. Okay.